FISSURE is Assured Information Security's open source RF framework that contains hooks for the entire RF reverse engineering process. This includes all things relating to monitoring, collection, replay, analysis, research, demodulation, injection, and vulnerability analysis. It also acts as a toolbox for all things RF and includes hundreds of commonly used open source tools along with tons of online reference material. The backbone of FISSURE is Python, PyQt, and GNU Radio. The framework was designed with experts and beginners in mind. Experts in RF and cybersecurity can use it as part of their daily work or add new methods, algorithms, or approaches to the framework to support the development of cutting-edge techniques. FISSURE has been on GitHub since August of 2022. The code is continuously evolving and improving over time. The open source nature of FISSURE is what sets it apart from other similar solutions. FISSURE is the software. It runs on general purpose computers and can control any type of sensor or radio hardware that you would typically control with a computer. So far, it has been primarily tested with COTS devices, but it just as easily could integrate with other GOTS solutions, including different types of platforms, sensor suites, networks, and computing hardware. There are multiple deployment options for FISSURE. The software and hardware can be contained on a single workstation, such as a laptop, and have radios and sensors plugged into the USB ports. FISSURE could also run a subset of its code on remote computers and execute various actions autonomously or through user interaction over a network. FISSURE relies on a central hub between the GUI and its modular software components. This hub relays messages, helps control automation, and accesses the FISSURE database from a central location. It could potentially run on a network location separate from the FISSURE dashboard GUI. In a similar manner, the data processing involved with the various tasks included with FISSURE could be offloaded to separate computers over a network, or pass data and messages back and forth to other third-party software tools. Here is a remote sensor node example. There's a laptop with the FISSURE dashboard GUI and the code for the central hub. It is connected over a Wi-Fi network to a mini PC and single board computer containing multiple commercially available SDRs. Each type of hardware in this diagram can be swapped for something else depending on the mission. FISSURE works with IP-based networks and is being updated to work with low throughput, unreliable comms like Meshtastic for doing basic actions like starting, stopping, beaconing, returning status, and alerts. We continue to showcase FISSURE at various conferences and expositions, seeking users and contributors. We are using FISSURE in non-DoD spaces like at the Orion Technology Accelerator in Rome, New York, and periodically in wireless security classes for the automotive industry. FISSURE relies on contract-driven development. We currently prioritize advancements based on customer needs and available funding. Otherwise, major improvements tend to occur more spread out over time. Certain aspects of the framework reside at different TRL levels. For example, some customers value the ability to deploy remote sensor nodes and run scripts outdoors, while others may want RF reverse engineering techniques in an office setting. We continue to collaborate with AIS's industry and defense partners to improve FISSURE and solve RF-related challenges. To learn more about FISSURE, visit the GitHub project page, which contains past presentation material, user manuals, installation guides, and links to helpful walkthrough videos.